there are multiple methods for graphing these functions. One method is to focus on just the part of the equation up to the x, 3 times 2 to the x. And then remember that this plus 1 means left 1, and the minus 4 means down 4. So you'd find the points for this basic equation, and then you'd move each of those points left 1 and down 4. This method is best when you don't have a graphing calculator, because then you can choose x values of like -1, 0, 1, 2. You can easily plug them in, and then you can move those temporary points left 1 and down 4. But my guess is that if you have a graphing calculator available, you want to do the least amount of work possible. Is that the case? So let's be strategically lazy and use our resources and put this whole thing in the calculator and then interpret what the calculator tells us. Because you can't just plug it in the calculator and expect the calculator to do everything for you. You still have to think a little bit outside of that. So if we're going to enter this into the calculator, on your graphing calculator, where do we enter equations? We enter equations in y equals. When you push y equals, I want you to look at your screen. Look at the top of the screen where it says plot 1, plot 2, plot 3. Do you see how one of mine is darkened? If yours is darkened like that, it will screw up your graphs. It will make everything not work correctly. So if you ever see that one of them is darkened, just arrow up until it's flashing and push enter, and that will turn that plot back off. You want all 3 of those to be blank, gray, not darkened. All right, type in 3 times 2 to the x plus 1 minus 4. 3 times 2 raised. When you push this caret button on your calculator, if it shoves you up into that exponent, see how I've got a little box that's flashing waiting for me to enter my exponent? That's a newer calculator. Then you can just type in x plus 1. If on your screen you see the actual caret symbol and it doesn't move your cursor up, then you need parentheses. And parentheses are never a bad idea, so I'm going to put the x plus 1 in parentheses. Excuse me. My cursor is still up in the parentheses. I need to push the right arrow to get down out of the exponent. And now I can type in minus 4. If you have an older calculator that doesn't shove your cursor up into the exponent, once you close the parentheses, your exponent is done, and then you can type in the minus 4. If we want to look at this graph, we can push the graph button to look at your graph. I notice that this graph looks like exponential growth. How do I know that it's exponential growth? It starts close to the asymptote and then moves away from it. Anytime the graph starts close to the asymptote and then moves away from it as it moves to the right, that is an example of exponential growth. And we'll be talking about this over the next few days, but the number that's raised to an exponent, that's going to determine whether it's growth or decay. So because that number is bigger than 1, this is an example of exponential growth. Take a look at the graph below this one. See how it's a 1/2 raised to the x? That one is going to end up being decay. If the number raised to the exponent is bigger than 1, it's growth. If the number raised to the exponent is a fraction or decimal less than 1, it is decay. All right, once we look at our calculator, we're not just going to estimate and draw a funky shape on the graph. We're using the calculator to do the work for us, so we're not going to be super lazy. We're going to get actual points from the calculator. To get points, you need to go into the table, which is above the graph button. So second graph button goes into the table. The biggest comment I hear on this screen is, my screen doesn't look like yours. I don't have the same numbers. You can move the up and the down arrow to move to a different place on this screen. So if you don't like the numbers that you're seeing or you want different numbers, push up or down and shift where you're looking on that table. I want to use points that are easy to graph and one point that has decimals. So I am going to choose, starting at -2, -2, -2.5, -1, -1, 0, 2, and 1, 8. So -2, -2.5. -1, -1, 0, 2. And 1, 8. Okay. Before I plot those points, there's a couple other things I want to notice. Where's the asymptote on this graph? Y equals -4. That's also visible in the equation. The number added or subtracted not in the exponent, that is going to give you your asymptote. So our asymptote is y equals -4, and I'm going to go to that horizontal line at -4 and draw in a dotted line. I use a dotted line because it's not actually part of the graph. It's just going to be a guide to help me when I connect my points. Now let's plot those points. -2, -2.5, -1, -1, 0, 2. The nice thing about using the graphing calculator is that if you want to put more points on there, you have a whole bunch of points that you can look at and add to your graph. So if you're ever uneasy about how to connect the points, you can always add another point. So I could add the point -3, -3.25 if I wanted to. Okay, it's important to draw in your asymptote because if you cross that asymptote, your graph is wrong. You will lose points. When you draw this in, you want to do a nice curve, not too jumpy, not too straight. And then on the left side, you need to approach and appear to just almost touch that asymptote, but definitely don't cross it. Because of the thickness of lead or the thickness of your ink pen, it might look like you are touching the asymptote. Just make sure that you don't cross it. I'm going to do something in red to show you what definitely not to do. Do you see a problem with what I just drew in red? It's curving back up. It looks like a fish hook. We are not drawing fish hooks. We are drawing exponential growth functions that approach an asymptote. So make sure that your graph approaches the asymptote and doesn't curve back away from the asymptote. Okay, now the domain and range. The domain is super easy. What's the domain? All real numbers. And actually, if you've taken the time to think through the asymptote, the range is also really, really easy. The range is going to be y, some symbol, and then -4. The range and the asymptote need to match. You just need to ask yourself one question. Are the points above the asymptote or below the asymptote? Above, greater than. If the points are above the asymptote, your range is y is greater than -4. All of your y values are bigger than that y value of -4. If the graph had been flipped and the points were below the asymptote, then it would flip this to y is less than -4. So if the points are above, then y is greater than. If the points are below, your range will be y is less than. I want you to try the second graph on your own. It's very similar to this first graph. I would start by thinking about your asymptote and drawing that in. You could even think about the domain right now if you wanted to. Put that whole thing in your calculator, find some points, get them plotted. If you're watching the video, pause the video, try this on your own, and then play the video again. Let's talk about the range. If your asymptote is y equals 1, your range is going to be y and something to do with 1. The points are above the asymptote, so y is greater than 1. Okay, this is another exponential growth function, and we can see that because it starts on the left close to the asymptote, and then on the right it moves away from the asymptote. If you start close and move away, it's exponential growth. You can also tell that by looking at the number that's being raised to the exponent. That's a 3, so it's exponential growth. The next one we're going to look at is exponential decay. We can tell that because it's 1/2 to the x, and that 1/2 is going to make it exponential decay. However, we're going to start out the same exact way we did before. So the +1 tells us what the asymptote is. Our asymptote is going to be at y equals 1. We need to enter this new equation into our calculator. Y equals button, clear out the old. Parentheses are your friend. I would enter this the same way it's written on the paper. -2, parentheses. For 1/2 in the graphing calculator, just do 1 divided by 2. 1/2 is 1 divided by 2. Close your parentheses, raised to the x, and then +1. Okay, here's what this graph looks like. It is decay because it starts away from the asymptote on the left, and then on the right it moves closer to the asymptote. This one is below the asymptote, and we can tell that in the equation because of the negative in the front. Remember yesterday, if there's a negative in front, it's going to flip that graph. Let's find some points to put on the graph. You get to choose what points you want to use. I think I'm going to choose starting at -2, -7. And I will use all of those points down to 2.5. -2, 1, 2, 3, 4, 5, 6, 7. Remember, make your graph appear to get really close to that asymptote. Because of the thickness of your lead or your ink, it's going to look like you're touching the asymptote. That's fine. Just make sure that you don't cross it. Okay, the super easy part. Domain. All real numbers. And the range has to be y and something with 1 because the asymptote is 1. But because the points are below the asymptote, because of that flip, it flips the range. Y is less than 1.